where we will use MLflow on Kubernetes. At this point where MLOps actually starts to feel real. Before we run any command, let's understand why MLflow is so important. In production, machine learning training or machine, uh, the let me open MLflow actually. So in production, machine learning, a training model once is useless if you cannot reproduce it. You need to know exact what data version, which code, which parameter, which environment produces given model. Without that, debugging, auditing, and improving model becomes impossible. MLflow solves this problem by acting as the system of record for experiment and models. So let's walk through uh, what what actually we are going to do step by step, and why, and at the same time I'm going to explain you what each part is doing. So first thing, we are actually going to install the Helm, install and upgrade. So we have already actually updated the Helm. So let's do one thing. Let's first upgrade Helm. So let's type, oh sorry, it's Helm. Oh, so first thing first, uh, we actually need to we have not added the any community charts. So let's actually bring the Helm community chart. So let me, then we can actually run this command. For that, we can type Helm repo add community charts, and you can, there are many community charts that you can I am going to use Helm charts. So let me paste the URL, and let's, community chart already exists because for me it's done. And then we can do the Helm repo update. Helm repo update chart repository. Now we are actually going to deploy the MLflow. So since for me it's going to throw an error, I already have the MLflow. So a good practice is to first kill the existing one. So you don't need to, but I am typing this command because since once you are going to uh, kill, I mean, we need to avoid any port forwarding already in use uh, Kubernetes clusters. So let's kill, because you are going to see such errors of a port already taken. So before installing that, let me remove existing, and this is going to be very helpful for you as scv/mlflow. If you face any error in this lecture, try to run this command. uh, it doesn't do anything, it won't do for you as well because we haven't installed the MLflow. So let's bring hyphen hyphen install MLflow and community. So I'll explain you what we are actually doing. So we begin by adding the Helm repository using that command Helm repo add community followed by Helm repo update. A Helm repository is a simple collection of pre-packaged Kubernetes applications called charts. By adding community charts repository, we gain access to production ready MLflow Helm charts that already encode best practices for Kubernetes deployment. So next step, what we are trying to do is here is to deploy MLflow itself. We do this by using Helm upgrade in hyphen install MLflow community hyphen charts slash MLflow. So this command is important. The word upgrade means deployment is idempotent. If MLflow already exists, Helm will upgrade it. If it does not exist, Helm will install it. This is what we want. This is the core MLOps principle. Infrastructure should be repeatable and safe to rerun. Now, the next step is, let's go to second line, and now let's define something. Uh, mhm, we, yeah, so what we are going to do is we are going to deploy this into the dedicated namespace called MLflow using namespace and MLflow hyphen create hyphen namespace. So namespaces are logical isolation mechanism in Kubernetes. As our platform grows, having separate namespaces for MLflow, Airflow monitoring will keep the system clean and manageable. Now let's talk about the backend configuration that we need to do. So till now, I hope I don't, although it's two line, but they are very important in terms of keeping the best mm, best practices. So now what I am going to type here is something that MLflow requires. So MLflow needs a store to persist experiment metadata, and we can enable Postgres by setting PostgreSQL as true. So how we can set? You have to use hyphen set backend store dot database migration equals to true, and that's how uh, by this is what we have to type. So what this will do, this is going to create the Postgres database inside cluster specifically for MLflow. We also configure credential using Postgres auth.username. So that's something you can again use these hyphen set and then Postgres. Let's Postgres 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 QL dot L equals to true, and let's also set SQL dot auth dot password is going to be it should be a long uh, very long complicated string, but for now I'm going to type password. Don't do that in production. This is just for me trying to set things quickly. Dot auth dot username is going to be MLflow, and again set PostgreSQL dot auth dot database is equals to, let's create the database with the same name. All right. Once this is done, we also need to enable database migration by setting backend store database migration to true. That we have actually done. So what this is doing, this ensure MLflow upgrades its schema. The database should stay compatible. Next is the artifact storage, which is one of the most misunderstood part of MLflow. Artifacts are the things like trained model, plots, serialized file. We configure MLflow to use proxied artifact storage by setting artifact root proxies flag to true. Then we define the default artifact location uh, to set the artifact directly to ML artifact. So what we are going to do is allows MLflow to serve artifact through its own server rather than exposing raw storage directly. This mirrors how MLflow is typically deployed in a secure production environment. So let's do that. Artifact, we have to type artifact root dot prox. I hope that I'm spelling everything correctly. Proxied artifact storage equals to true. Perfect. Now we have enabled it, and now let's di float dot uh, default storage default artifact uh, root. Let's set this to MLflow artifacts slash ML ML artifacts. Great. And uh, so final thing, now we also need to pass the environment variables and flag for MLflow server. What what we in this setup, we allow the MLflow UI to be accessed from local browser during the development. So this is something which is not recommended for that I'm going to do for the prod environment. But yeah, this is something you should do for only for local development. When you are doing the deployment, you can specify the IP ranges that you are going to allow. For now, I am actually going to set the environment. So this something is called extra env wars dot ml flow. Don't worry about the codes, and I'll make sure that I'll commit all of the files. Uh, so you can copy paste from there. In case if I'm going to make any typo on that file, it will be corrected. I'll make sure that. So understand that why we are doing this, because this is locally and we want our UI to be accessed. And now what we are trying, next thing we should do is to bypass is by serving like we enable uh, the artifact serving by passing server artifact using extra flag, and we define the local artifact destination using again extra var artifact destination as temporary ML artifact. So this is something also we need to make sure that where we are going to store the extra env, sorry, it's extra args dot artifacts and destination, and then the path name slash, and let's also set extra flag 0. Artifact. So make sure that this command is ready, and let me actually, I have made one typo, and let me copy paste this thing. It's extra flag 0 server artifact extra extra artifact. All right, let's do one thing. Let's create a file. Actually, it's better you create. Anyways, I'm going to ship this. So let's add the command that we are going to run in the sh file, and let's also do one thing. Once the Helm is going to actually install, Kubernetes still needs time to start the pods. So let's do one thing for kubectl. Let's wait -4, the for condition that the above is ready. And we need to tell uh, that it is a name with the MLflow. So let me actually grab that command. So this is what is going to wait for MLflow, and it will time out after 5 minutes. This much time we are going to wait for the MLflow pods to be ready. What essentially this command is going to do, this command is going to block until MLflow pods are actually ready. Without this step, we might try to access MLflow before it is available. So next step is, this is again for the local. You can omit, but better to learn. In the prod environment, because it's a local Kubernetes cluster, and we use kubectl port forward. This maps the port 80 of MLflow service inside the cluster to the port 8081 of your local machine. So you can open the browser and see your MLflow UI without exposing the service publicly. So this is something which is good practice. So let's do that. And once this is done, let's actually print MLflow is ready, and let's also print the address. It's actually good practice. Host 8081 I believe now how we are going to run this. You can make it executable. X dot MLflow setup. Oh, wrong spelling. Chmod. Now we can run this file. Perfect. Now let's wait for it to install the MLflow. Then I'm going to show you the MLflow UI, where you will show you where will all the experiment and all will be present. So in this channel, I have made an extensive course on MLflow. So I assume that you have watched that, but if you have not, I'll link the complete series to this video, because this is an upgrade to that video. And uh, because now I'm going to write a training code which essentially required for us to have the working knowledge of the MLflow itself. And this much is actually, I would say, this is all a bit advanced course. So if you have any confusion of what I am going to do the next, you should probably watch that series, and it's going to be very helpful. So let's do one thing. Since I need to run the uh, model training, usually it's separate environment, but I'm going to use that same folder. And then what we are going to do is create a virtual environment and then write a training script, connect to the MLflow, and connect to the MLflow that we are actually in the process of creating. Run the training job, see if that training job is working, and this much how to connect with that. This much we are going to cover in the same video. So let's do one thing. Let's create UV, VE, and V. Oh, one thing. Let's do UV init. It created an empty. Let's create UV, SY, and see. It's going to make a virtual environment. And also, if you don't know what is UV, then again there's a video in this channel to understand what I'm doing here is just creating a Python environment. Perfect. We are using our environment. Let's come here and let's rename this file to something train ML flow. And I am actually going to add some dependencies. So uv add MLflow sk scikit hyphen learn. Let's also bring pandas. Yeah, that's pretty much, we are going to keep that lightweight. And let's run it. It's installing. Let me bring our data. So this is our diabetes. uh, it's going to predict this target variable, which is, this is the target variable, this is our feature vectors, and we are not going very deep into that because our objective is to train this model on that target variable. And I'm going to use a very lightweight model for that. So let's actually go and start doing things. Let's see if our MLflow Helm is done. Perfect. As you can see, our MLflow is working. Do we have an experiment? We don't have anything right now. It's a clean slate. We can start. If it is working this much, that means you are ready for writing the MLflow code. So first thing first, let's import MLflow, and let's if name main. It's very important, and we need to configure MLflow to point to our K8 instance, because MLflow is running on Kubernetes. So let's use it in the way that it is meant to be used by tracking a real machine learning experiment. I'm going to walk you through this training script, and I want you to notice something important. Although there is nothing toy about this setup, this is exactly how MLflow is used in real production pipeline. So let's start with this. Let's first open the tracking URI. So we can get this from OS. So also let's import os dot get env MLflow tracking URI. We will get from the environment, but if it's not able to find, then let's also give this a default value. Local host 8081. Perfect. And then we can set our client set to tracking URI as tracking URI MLflow dot. Now we can set the experiment name. Experiment as since let's call it, we are going to use elastic net model, so let's call it diabetes elastic net, and let's call it v1. Perfect. Now let's import our data from the folder. Let's mark the data path. The data is in the data slash CSV, and there is a huge possibility in our cluster this path won't resolve. So let's actually so let's do one thing. If not, os.path dot exist, if this path dot does not exist, and then we can we need to, what can we do? And then in that case, can we create the database itself? So let's do one thing, because there I want to show you, like, if your data, there is a you need to provide a possible pathway for our data to exist. So let's create one more file. Let's name it export data.py, and we will keep our separation of uh, loading the data from the training code. So for now, from sklearn dot datasets, let's use some pre-built data. Load diabetes, import OS. So let's define export data, and then let's load the data set, and then you can use let's import also import pandas as PD. So PD dot data frame diabetes dot data and columns diabetes dot feature names, and we can define our target diabetes dot target. Perfect. OS dot make directory slash let's make it as data, and then exist. Okay, true. And second thing is let's also define the data path. Same, we can also take it from there, but diabetes dot csv df to csv data path comma index. Let's not give it, and let's print data creation done, and if name is equals to, then we can call our export data. Let's export. Let's test this. I'm actually going to delete. Let's delete this, and you will run export data. Hopefully we will be able to create the data set. It's actually downloading it. What is happening? Perfect. Yeah, we have the data, so nothing to be worried. Now we can come here. If the case where so we were trying to handle, if our data does not exist, then in that case let's import. Should we do import? Yeah. So from export data, import export data, and then we can call this function, and let's also import as pt tf is equals to pt dot read csv, and we can pass the data path, and x is equals to df dot we can just drop the last column, and in x is equals to 1, 0 is the row, and we can get df. Actually we can get the direct target. Perfect. Let's also from sklearn, let's get the train test split. So I think it's in the sklearn dot model selection, import train. I believe it's in the oh sorry train test split. Also, let's import some other dependencies as well. sklearn dot matrices. Let's import mean squared error, and also let's absolute error also, and let's also measure R2 score. Perfect. This much we will require. And when this is done, so let's create the train X, train Y, train X, sorry, it's test X, test Y, train test split. Let's only pass the X comma Y. All right. So now we have the data. We can start the training. Let's define the important parameter for training, 0.5 for alpha and 1 ratio. And now, because why I'm doing this, it's not important. I want to actually load some of the parameters in the MLflow. MLflow dot start run. In this context, this is important. In this context, we are actually going to uh, we have not imported the model. Uh, okay, let's do one thing. From sklearn dot linear models import elastic net. Perfect. Elastic net. And then we have to initialize this. Let's define the alpha and L1 ratio as L1 ratio, and the random state for 1, 2, 2, 2, 2, 3. Fine. And let's call the fit method. This is actually going to train our learner lr dot fit. Let's pass the train x comma train y, and we can now actually, as we do this, let's when this is done, let's loss prediction is learning dot predict on test test x, and we can now let's make one more function outside this. Let's call this eval matrices. Def eval matrices actual versus predicted, and let's call the RMSE is mean squared error, and we can pass actual comma predicted, and take the root square under root. Mean absolute error. Again, let's pass actual predicted, and let's calculate the R2 score. Actual and predicted, and let's return RMSE, MAE, and R2. Perfect. Let's come here, and now we can actually invoke this function, and let's call the eval matrices. So the actual value is the test test y comma pre. So what this is going to do, it's actually returning three things for us. First thing is RMSE, MAE, and the R2. Now since these things are important, so we are actually going to log them. How can you log it? So you call the log param, and let's log alpha. Let's copy and paste this multiple times, and let's L1. Why I'm doing this? Because for this experiment, these were the values RMSE and then MEA, then we can call R2, and then we can call the R2. Perfect. And once we'll log the parameters, let's register this model. So mlflow.sklearn.log model sk, there is called sk model is the LR, and then artifact path is model, and registered model name, let's give this name as DEM, and let's print done if everything goes well. Whew. Let's go run it. UV run train MLflow.py. Hopefully there is no error. One thing that I did here, for some people it might maybe they can think why we are not uh, written in the same function. So it's actually, you can perfectly do that, and separating this logic into a function is intentional. In production, metrics calculation is part of your contract. You actually want it to be isolated and reusable and testable. So because of this, I have moved that out of the main block. Let's give this some time. So also, like, meanwhile, I'll explain you what this is. So here, uh, everything that happens inside this block is automatically associated with a single experiment. Think of this as a transaction boundary for your machine learning job. Inside this run, we are initializing the elastic train models and then generating predictions, then compute metrics. At this point, this this is something we have done, and then logging the matrices. Finally, we were calling the sklearn log model artifact path, and we provide the registered model name. So far, so good. This single steps promotes the model from just file to a managed asset in model registry. So from this moment onward, this model has version, lineage, matrices, history. It can be promoted to staging, production, or rollback, exactly like a real production ML system. At once this is done, our experiment should get log here. Let's wait for this. So what I wanted to show you is you people to realize that MLOps is not abstracted. It is concrete and inspectable and auditable. And this is, by the way, just the beginning. In the next module, we will build automation pipeline on top of this, turning individual runs into repeatable production grade workflows. All right, failed to get mixed retry existed. So I can see there is a connection issue. Get by name. Oops, sorry, because of that simple typo. It should be localhost. Okay. sklearn. Oh, sorry, it is log model. It's better that we are getting some error. All right. Yes, that's what I mean. Perfect. Let's see. Yeah, finally we can see. So look, our failed experiments are also here. Our past experiments are also here. And you can see them. Model matrices, traces, artifacts, conda, model file, and its requirement, what it requires to be get installed. Environment also. Everything, like from this onward, this can be reproduced anywhere. Like, and we can see this model is registered with DEM, and all of the informations are here. Input, output. This is something that we have covered in more detail to how to populate these things. And yeah, you can follow that lecture for more detail, deep dive into the MLflow. But for now, our base is ready. We won't be writing that much Python code again, because next thing we will be uh, managing this through the K8s Kubernetes. Yeah, one more thing is how can we serve this model over the API. So for that, we are going to write the Flask API. And yeah, thank you very much.